Certainly, let's talk about traveling to Earth-shaped planets. Firstly, it's important to note that currently we don't know of any Earth-shaped planets in our own solar system. However, there are plenty of exoplanets, planets outside of our solar system, that have been discovered that are similar in size and composition to Earth. The first challenge in traveling to these planets is actually finding them. While we have become quite adept at detecting exoplanets, the vast distances involved make it difficult to know much about them beyond their size and basic composition. Assuming we do find a suitable Earth-like planet, the next challenge would be getting there. With current technology, the distances involved are simply too great to travel to other stars in a reasonable amount of time. Even the nearest star system, Alpha Centauri, is over 4 light-years away. However, there are some proposed methods for interstellar travel that could potentially make it possible to reach these Earth-like planets. One such method is using nuclear fusion propulsion, which could potentially allow spacecraft to reach speeds of up to 10% the speed of light. Another proposed method is using antimatter propulsion, which could theoretically allow spacecraft to reach even higher speeds. Even with these potential methods, however, traveling to an Earth-like exoplanet would still be an incredible feat of engineering and would likely require significant advancements in technology. And once we got there, we would have to deal with the challenges of landing on and exploring a new world with potentially unfamiliar environments and potentially hostile conditions. In summary, while traveling to Earth-like planets is an exciting possibility, it remains a significant challenge with many technological hurdles to overcome. Nonetheless, the search for exoplanets and the exploration of our universe continues to be an important area of scientific inquiry and discovery. Sending humans to other planets is a complex and challenging task that requires advanced technology, careful planning, and a lot of resources. Space rockets are the primary means of transportation for humans and their equipment to reach other planets. Here are some key aspects of space rockets and their role in human space exploration. Rocket design. Space rockets designed for human space exploration are often multi-stage vehicles that consist of multiple parts or stages, each designed to perform a specific task. The first stage is typically the largest and contains most of the rocket's fuel. It is designed to provide the initial thrust needed to lift the rocket off the ground and into space. The second and third stages are usually smaller and designed to provide additional propulsion to reach the target destination. Propulsion. Rockets use different types of propulsion systems to generate the necessary thrust to move through space. Most rockets use a chemical propulsion system, which involves burning a fuel and oxidizer to produce hot gases that are expelled out of a nozzle at high speed to create thrust. Other types of propulsion systems include nuclear propulsion, electric propulsion, and solar sails. Payload. Payload is everything that a rocket carries, including humans, equipment, and supplies. When designing rockets for human space exploration, payload capacity is a crucial factor. The payload can include things like habitats, life support systems, communication systems, scientific instruments, and vehicles for surface exploration. Launch. The launch process is one of the most critical and challenging aspects of human space exploration. Rockets are launched from specialized launch facilities, which provide the necessary infrastructure and support to ensure a safe and successful launch. During the launch, the rocket must overcome the Earth's gravity and atmosphere to reach orbit. Interplanetary travel. Once the rocket reaches orbit, it must then travel through space to reach its destination. Interplanetary travel requires careful planning and precise timing to take advantage of the planet's relative positions and velocities. During the journey, astronauts must deal with the challenges of long-term spaceflight, such as radiation exposure, microgravity, and isolation. Landing. Landing on another planet is one of the most difficult and dangerous aspects of human space exploration. The landing process requires a complex series of maneuvers to slow down the spacecraft and land safely on the planet's surface. Once on the surface, astronauts must deal with the challenges of operating in a hostile environment, including extreme temperatures, dust, and radiation. Overall, sending humans to other planets is an incredibly challenging and complex undertaking that requires advanced technology, careful planning, and a lot of resources. Space rockets play a critical role in this endeavor, providing the necessary propulsion and infrastructure to transport humans and their equipment to other planets. The amount of fuel needed to travel to other planets in our solar system depends on a number of factors, such as the distance between Earth and the destination planet, the speed at which the spacecraft is traveling, the weight of the spacecraft, and the type of propulsion system being used. One important factor to consider is the Hohmann transfer orbit, which is a common method used to transfer a spacecraft from one planet to another. This involves a spacecraft being launched into an elliptical orbit around the Sun that intersects with the orbit of the destination planet. The spacecraft then uses its engines to adjust its orbit so that it intercepts the planet at the correct time and location. The amount of fuel needed for this transfer depends on the distance between the planets and the speed at which the spacecraft is traveling. The further the distance, the more fuel is required, as the spacecraft needs to accelerate to a higher speed to overcome the gravitational pull of the Sun and reach its destination in a reasonable amount of time. The weight of the spacecraft is also a factor, as a heavier spacecraft requires more fuel to accelerate to the necessary speed. The type of propulsion system being used is also important. Chemical rockets, which burn fuel to produce thrust, are the most common propulsion system used for space travel, but they have limited efficiency and require a large amount of fuel. Other propulsion systems, such as ion engines or nuclear thermal rockets, offer greater efficiency but may require more complex and expensive technology. In general, the amount of fuel required for a mission to another planet is carefully calculated by engineers and mission planners, taking into account all of these factors. The spacecraft is typically launched with enough fuel to reach its destination and perform its mission, as well as additional fuel for course corrections and emergency maneuvers. Refueling in space is currently not practical, so the spacecraft must carry all the fuel it needs for the entire mission. Surviving on other planets will depend on the specific conditions of the planet. However, there are some general principles and technologies that can be applied to increase the chances of survival. Here are some steps that could help. Understand the planet's environment. Before embarking on a journey to another planet, it is important to study the planet's environment, atmosphere, temperature, gravity, and other factors that will affect human survival. This will help in developing the right strategies and technologies to overcome the challenges of living on the planet. Develop a self-sustaining habitat. On another planet, it will be essential to have a self-sustaining habitat that can provide oxygen, food, water, and other essentials for human survival. This can be achieved through the use of advanced technologies such as hydroponics, 3D printing, and recycling systems that can extract and reuse resources from the environment. Protect against radiation. Radiation is a major concern for living on other planets, especially for those without a protective atmosphere like Earth's. Therefore, it will be important to develop protective shielding and radiation-resistant materials for habitats and spacesuits. Adapt to the planet's gravity. The gravity on other planets can be significantly different from Earth's, which can affect human health and mobility. Therefore, it will be important to develop exercises and technologies that can help humans adapt to the new gravitational conditions. Establish communication and supply lines. In order to survive on another planet, it will be important to establish communication and supply lines with Earth or other human settlements. This can be achieved through the use of advanced communication technologies and space vehicles that can transport resources and people. Continuously improve and innovate. Surviving on other planets will require constant innovation and improvement in technologies, strategies, and practices. Therefore, it will be important to continuously test and refine solutions to overcome the challenges of living on another planet. Overall, surviving on other planets will require a combination of advanced technologies, scientific knowledge, and innovative thinking. It will be a challenging and rewarding endeavor that will require the collaboration of experts from various fields, including engineering, biology, physics, and more.